Hi all. Today let us understand what is a superposition theorem and how we can do circuit analysis using superposition theorem, particularly while there is multiple sources of energy in the circuit. Uh, so, as per the definition, it says the superposition theorem states that in any linear bilateral network containing more than one independent sources, the current or voltage across any element in the network is the algebraic sum of the currents or voltages produced by each independent sources acting alone, while all other independent voltage sources are replaced by their internal resistances and all other independent current sources are replaced by open circuit. Now, what it is trying to say is, let us assume that we have a circuit like this, where this is R1, this is E1 with internal resistance R1, and this is R2, and this one is R3 with voltage E2 and internal resistance R2. Right. What it is trying to say that if we want to find out the current through R2, or this A and B, between this A and B terminal, this R2 is connected, and if we want to find out the current through this, so what we are going to do is we will first replace this E1 with its internal resistance R1, and then we will find out how much current is flowing because of E2 alone. Let's say this is I2. I2 is the current flowing because of E2, and then we will replace this E2 with this R2 and activate this E1 again and find out how much current is flowing because of this E1. Let's say it is I1, so the total current would be, total current IT should be I2 plus I1. That is the current through this branch, and that's what superposition theorem is telling us. Now let us take an example. I mean, let us take the values of R1, R2, R3 so that we can calculate. Now, for simplicity of calculation, let us consider 10 ohm in all uh, the resistance. So this is let's say 10 volt with the 2 ohm, 10 volt 2 ohm, and then again this is 10 ohm resistance, and again this is this is 10 volt 2 ohm, and this is 10 ohm. Now, right, so what, as per the superposition theorem, is that we need to replace this with 2 ohm. So it will become how much? 10 plus 2, 12 ohm. 12 and 10 in parallel. So how much is the resistance? 10 into 12 by 22. So this is 120 by 22. Let me calculate how much it is. It's become 5.4. Okay, so it is become 5.4 ohm. Now, so the equivalent resistance is going to become like this. This is 5.4 ohm, and then this is 10 ohm. This is 5.4, this is 10, and this is 2 ohm with the voltage source of 10 volt. 10 volt 2 ohm. So what will be the current through this? Uh, Current through this is going to be 10 by 10 plus 2 plus 5.4. So it becomes 10, 12, 17. 0.4, 10 by 17.4. So 0.57, 0.57, and the direction of the current in this case would be here. So it is flowing from this side to that side. So let us say this is I2. So let us understand that I2 equal to 0.57 ampere. Now, in the same way, if we find out there is one small mistake. This 5.7 is flowing through this branch. 0.57 is flowing through this branch. So it will be divided into this and this two branches. How much would be that? So if I want to find out how much would be the current to this branch, so as per the current dividing rule, we can find out the current like I2 equal to, that is the total current, right? This 0.57 is the total current is flowing through this circuit. So this one. So after that it is going to be varied, right? So this is 10 ohm, and this portion is 10 plus 2, 12 ohm. So 0.57 into it is 10 by sorry, it is 12 by 10 plus 12, right? So this is the formula for current dividing rule. Now let us calculate how much is that. 0.33. So now 0.31 amps. So this is what I2 is. This is I total IT, because we have find out the equivalent resistance of the second part, this part of the circuit, which is coming around 5.4. That is why it is this current is actually representing this current, which is again divided into two part. Now we need to do the other side calculation. I took it exactly the same, because so that I don't need to do the calculation here once again. So in this case, I need to eliminate what, this one I'll eliminate, and I'll calculate the same thing again. So again it is going to give the same value, because this is 10, this is 2, so 10 plus 2 is 12, and this is 10, so 10 and 12 in parallel. So 10 and 12 in parallel, and R1 R2 is 10 plus 12, 22. So this is the equivalent resistance. So since this is the equivalent resistance, we'll get the same value again, and with the same value, now it is here. This is the total current as 0.57. So this current will flow through this as well as this. Now again the same calculation, the current dividing rule. So this is 12. So this low resistance path will give high current. That is why 0.57 into 12 by 10 plus 12 is a 10 plus 12. The current is again 0.31 ampere. So I2 is, this one is I2. I2 is 0.31. Again this one I1 is also 0.31, and both of them are moving in the same direction. So total current IT would be I1 plus I2, that is equal to 0.31 plus 0.31, which is 0.62 ampere. So this is how we can find out the current of any branch in a circuit where there are multiple sources, voltage or current sources available. I hope you have understood this superposition theorem. Thank you.